What's up, stats? This is Mr. Carlson, C Squared Mathematics, and today we're getting into our last unit, Unit 8, Statistics. So we only had 2 units this course for stats, and that is Unit 7, Probability, and then Unit 8, Statistics. You guys just finished the test on Unit 7, so now what we're going to be doing is Unit 8, Stats. What and how are probability related to stats? How are they related? How are they connected? We're going to get started on seeing that connection, seeing that relation with 1.1 through 3 data classification and collection. So after that, we're going to jump all the way back to chapter 5, 5.1 in normal distribution. But before we do anything like that, I'd like to take a break and just get into something that's very, very simple. A lot of vocabulary today, not a lot of math, just tons of vocabulary of what makes stats and how we can actually calculate and collect and classify certain data sets, because really that's what stats is. So let's get started. I have these bell work questions that I want to get through, and this is just from your Unit 7 test. So let's get started on these. Okay, so this one right here is 35 members on the board of directors for a certain nonprofit institution. So there's 35 total. If they must select a chairperson, vice chair, second vice chair, and second secretary, how many different slates of candidates are possible? Now, this is definitely a permutation versus combination question. So the thing that you need to ask is, does rank matter? And because there are specific ranks, chairperson, vice chairperson, second vice, and so on, it is going to matter how we rank them. So I'm going to be doing 35 permutation. And then how many different things do we have? How many different ranks do we have? We actually have 4. So secretary, second vice, first vice, and chairperson, so 4. So I'm going to do 35 permutation 4. 35 permutation 4. After I do that really quick on the calculator, you can use Desmos or you can use like a TI-36X Pro like what I use. It doesn't matter. Okay. After you plug that in the calculator, you get 125,6640, which is a really big number, but it's 1,256,640. Yes, it's that many different ways. If I wanted to plug it on Desmos, I'm not going to show you right now, but if I wanted to plug on Desmos, you do NCR and then parentheses, and then you do 35, 4. That would be literally how you plug it into Desmos. Verbatim, word or letter for letter. Okay. N, capital C, R, and then 35, 4 in parentheses. Or sorry, not a C. You would do permutation. So after you plug that into Desmos, just like that, you would get that answer. That's how you'd plug it in. And it's that simple, okay? Remember, it's rank, so permutations. 2 cards are selected from a standard deck of 52 cards. The first card is replaced, so that tells me automatically if it's replaced, it's going to be independent. Okay, and then the second before the second card, find the probability of selecting a diamond. So diamond, and then a queen. Okay, so what's the probability of a diamond? That's going to be 13 out of 52 times how many queens are in the deck. There's actually 4 out of 52. So 13 times 4 is 52, but 52 squared, or 52 times 52, is going to be 2,704. So when I simplify this, so 52 all over 2,704, when I simplify this, this actually gives me 1 out of 52. Okay, and that's all you have to do. That's it. Promise. Okay, coin is tossed and a 6-sided die is rolled. They definitely have nothing to do with each other. It's a coin and a rolling of a die. So find the probability of tossing a head, and then rolling a number greater than 2. Okay. So tossing a head, well, there's 1/2 out of there, and then times, because it's and, a number greater than 2. So that's 3, 4, 5, 6. So that's 4 numbers on a 6-sided die that's greater than 2. So that's 4 out of 6. So this is 4 when I multiply. 2 times 6 is 12. When I simplify this down, this is going to be 1/3. So my probability of tossing a head and at the same time rolling a number greater than 2 is 1/3. Okay, so not a lot of questions I wanted to go over. I just wanted to go over a couple of them, and that's all I wanted to do. So let me erase, and then let's get started. Whoopsie. Let me go back. So what are we going to be doing? We're going to be looking at what considerations have been made when collecting data. What considerations do we make when we do collect data? And so when we look at data and we try to find out how to do math on it, we need certain considerations. We need to make sure we consider certain things when actually collecting that data. Okay, specifically considerations between the sample and the population. So let's actually get into it. Again, a lot of this lesson is just going to be straight vocabulary. Okay, straight vocabulary. So it is a lot of writing, but it's a lot of it's just going to be vocabulary. A population is the collection of all outcomes, responses, measurements, and counts. So like I said, if in contrast with a sample is a subset or part or a population. So if MHP is a population, my classroom is the sample. If Casa Grande, Arizona is the population, then Walmart would be a sample. Okay. If the school districts, the three main high schools, Mission Heights, Vista, and Union, in Casa Grande are the population, then Vista would be a sample. Okay. Does that make sense? If you have a 5-person family, the 5-person family would be a population, but you yourself, or maybe like the children, would be a sample. All right. Hope that makes sense. So that's population sample. Let's get to an example of how to find them. So a recent survey, 614 small business owners in the United States population were asked whether they thought their company's Facebook presence was valuable. 258 of the 614 respondents said yes. So identify the population and then the sample. And then we also want to describe the data set. So the first thing, what's my population? Well, the population is actually all business owners. Okay? So all business owners in US. So in US. Okay, that's really what it is. Okay? That's all business owners in the US. So that means my sample is actually that 614 business owners. So that is, wow, don't know how to spell here. 614 business owners. Okay. Now what's my data set? My data set, what I'm actually going to be using is that 258. So this 258 from my 614 of owners said yes. So 258 owners said yes. And then we can also find the complement of that by just subtracting it from 614, and that would be 356 said no. Okay, so that is not technically given in the problem, but we can find it by just taking 614 and then minus 258, and then we can get 356. Not too bad, right? All right, let's move on. So U.S. Department Energy conducts weekly surveys of approximately 380. So I want to find my population, my sample, and then of course I want to find my data set because it's just like the previous problem. Sorry about my handwriting here. Okay, 800 gasoline stations to determine the average price. Now on December 10, 2012, the average price was this. Okay, identify the population sample, and then of course describe the data set. There should be a period there. Sorry, describe the data set. Okay, so all gas stations, of course, is my population. All gas stations is the population. My sample is really just the 800 that I'm looking at. So the 800 gas stations, that is my sample here. And then my data is going to be what's given to me, so that $3.35 per gallon. So the $3.35 per gallon. Okay, that is going to be my data set. Hope that makes sense. Okay, not too difficult. Let's get into 1.2 now. So this is that was just 1.1. Very simple, right? Population and sample. Let's get into 1.2 because we have to get through at least three lessons, right? So this is 1.2, going over what we call qualitative and quantitative data. Qualitative and quantitative data. What is the difference? Well, qualitative data consists of attributes, labels, and non-numerical entries. So unicorns, leprechauns, werewolves, those are all qualitative data because I'm actually saying a word. But quantitative data, on contrast, is numerical measurements and counts. So 1, 2, 3, 4, 5, how many people in my classroom? Okay, how many people in my household? How many action figures do you own? How many Instagram likes do you have? All that fun junk. That is going to be quantitative. So quantitative is numbers. Qualitative is like descriptions. Okay. All right, my nose is bothering me. So the suggested retail prices of several Ford vehicles are shown. Which data are qualitative and which data are quantitative? So this right here is my qualitative data. Okay, my qualitative. This, because it has numbers, this is what we call my quantitative data. All right? And that's that simple, guys. Numbers include quantitative, descriptions is qualitative, and that is it. Okay? Same thing here. Population of several US cities are shown in the table. So which data are shown or are qualitative and which data is quantitative? So here, right here, this is going to be qualitative. This is going to be qualitative because it's quality, because it's a description of a city. This right here is quantitative because it's an actual number. Okay? So when it's a number, it's quantitative, like quantity. Think of quantity. If I ask you what's the quantity of how many cell phones you have, you're going to say a number, okay? I have 2, I have 3 cell phones, I have 1 cell phone. If I ask you the quality of something, like the quality of your jeans, you're not going to shout out a number, are you? You're going to shout out, well, they're good, or they're pretty great, or they're really crappy. You know, they have a few rips. Those aren't numbers. Okay, those are qualities. That was 1.2. We're just going along on here, so we're going to go to 1.3, and this is going to be the vast majority of our time together, 1.3. Okay? So 1.3, here are the guidelines, and you'll be writing these out. If you're following along in a note packet, if you printed off the note packet, you should be following along, and these are the guidelines. Identify the variable of interest and develop a detailed plan for collecting data. If you use a sample, make sure that the sample is representative of the population. You're going to collect data, and then you're going to describe the data using descriptive statistics. Okay? Next, you're going to interpret the data and make decisions about the populations using inferential statistics, and then identify any possible errors. So we're going to do, if you were on campus, we would actually do like a awesome project where you actually go out and collect data. Okay, but since you're not going to do this, that doesn't mean it's meaningless, okay, because you still need to know this for your homework. But these are the actual steps when designing a statistical study. You would identify the variable, develop a detailed plan, collect the data, describe the data, interpret the data, and then you're going to identify any possible errors that you could have. Okay, there are several ways to collect data, of course. Okay, often the focus of the study dictates the best way to collect the data. So if you focus as in like an observational study, then a researcher does not influence the responses. If you did an experiment, the researcher applies treatment before observing responses. If you have a placebo, that just means a harmless or fake treatment, essentially. A simulation, so that's a use of mathematical or physical models to produce the conditions of a situation or process. And then a survey, an investigation of one or more characteristics of a population. So that's like basically what you're trying to do is not word questions as to not lead to bias. You don't want to word questions to lead to bias. So wording questions specifically as to not lead to bias is really your goal. If you're doing a statistical study, you don't want to basically have a loaded question. You know, like why do you shop at Lowe's when it really does suck? Obviously, that's a loaded question, right? Because you're saying, oh, you have a bias there because you hate Lowe's, and that's why you said it in your question there, right? So the reason why I starred these is because those three, 1, 2, and 5, are survey, observational, study, and experiment. Those are the ones that we're mainly going to be talking about the most. Okay, so let's go through a couple examples here. Determine whether or not it's an observational study or an experiment. Researchers study the effect of vitamin D supplementation among patients with antibody deficiency or frequent respiratory tract infections. To perform the study, 70 patients received 4,000 IU of vitamin D3 daily for the year. Another group of 70 patients received a placebo daily for 1 year. So is this experiment or is this an observational study? Now, think about it closely. This is actually because it applies treatment, because you're actually applying treatment here. Okay, that's very important. It's what we call an experiment. Since we're actually applying treatment, it's what we call an experiment here. Okay, that's the main thing. All right. The next one, researchers conduct a study to find U.S. public approval rating of the U.S. public approval rating of the United States president. To perform the study, research call 1,500 U.S. residents and ask them whether they approve or disapprove. Now, since there's no treatment here and they're just kind of taking a poll and seeing whether or not they approve or disapprove, so seeing whether they approve or disapprove, this is what we call an observational. Okay? This is what we call an observational study. All right? Sometimes you may see survey. This could possibly be a survey as well, but more than likely it's going to be an observational. And then last, Pennsylvania Game Commission conducted a study to count the number of elk in PA. Okay, the commission captured and released 636 elk, which include this much stuff: 350 cows, 125 calves, 110 bulls, and then 51 spikes. So is this observational or experimental? But since there is no treatment, again, so no treatment, it's also going to be observational. No treatment means observational. All right? Perfect. Okay, let's erase. Sampling techniques. What are sampling techniques? Sampling techniques, there's a variety of them. First of all, there's a census. Okay, here are some definitions. Okay, first of all, here you can take a census, you can take sampling, or you can take a sampling error. So here are some definitions before we actually get into sampling techniques. So definitions: a census is just a count. We had a census at 2020. So a count or measure of the entire population of the United States. Sampling, count or measure of part of the population. That's most likely what statisticians actually do. Sampling error, the difference between the results of a sample and a population. Okay, now sampling techniques, here are the actual techniques. There are several commonly used ones, okay, but they each have advantages and disadvantages. So stratified sample means this: members of the population are divided into two or more subsets, called strata. Cluster sample means divide population into groups, called clusters, then select all members in one or more clusters. Systematic sample: each member of the population is assigned a number and then selected at regular or repeated intervals. So like every 5th person, every 10th person, every 2nd person, or so forth. That's systematic. Okay. Convenient sample. To continue on, convenient sample: members of the population that are easy to get. So if you're surveying people in the population or in the sample, you probably want to survey people at your school because they're easy to get, right? Every member of the population has equal chance of being selected. That's random. And then simple random sample is just every possible sample of the sample size has the same chance of being selected. Now, obviously, simple random is probably not true. Okay, simple random, it's very difficult to get a simple random, a simple random sampling technique because it's just not possible that every possible sample of the same size has the same chance of being selected. Okay, that's just not true. Okay, every possible member of the same size. Okay, but more than likely, what we're going to be doing is sample, a random sample, where every member of the population has an equal chance, okay, of being selected. It's a little bit different there. So using a simple random, we would use Desmos. Okay, if 28 students are currently enrolled in statistics class, you wish to perform a random sample of 8 students to answer some survey questions, select students who will belong to the simple random sample. Okay, really this depends. It's really hard to kind of show you this, but what you would do on Desmos is you would actually type in 1, 2, 3, all the way until 28, just like that, and then do dot random. What this will do is it will generate a random number for you. So select students who will belong to the simple random sample because you would actually like number them off, and then that's how you would solve it. I really can't show you anything more than that, but that's how you would plug it into Desmos. Okay? Let's get through some other examples. You are doing a study to determine the opinions of students at your school regarding stem cell research. Identify the sampling technique you are using when you select the samples listed. Okay, discuss potential sources of bias, if any. So you divide the student population with respect to majors and randomly select and question some students. What is this? Because you divide the student population, okay, and then you randomly select and question some students within that major, this is what we called a stratified sample. That's stratified. Okay, look back at your definition, but stratified is basically dividing into 2 or more subsets, and that's what you did. You divided into 2 or more subsets. This one, you assign each student a number and then generate random numbers. You then question each student whose number is randomly selected. This is what we call simple random. Okay, simple random sample. All right. Sort of what I showed you on Desmos, you would assign each one a number, and then it just pops out a random number. That's it. Okay? Simple random sample. Next, you select, let's go through all, you select students who are in your biology class. Well, this is convenience, okay? Because they're in your biology class and you don't need to go far. But it's also what we call bias. Okay, this is a bias. Select any sources that are biased. Why is it biased? Because bio students know more. Okay, that's what I would say. Bio students would tentatively know more about stem cells. Okay, so if you actually want to do a research on stem cells and you do a bio, right? Bio students tentatively know more. That's why it's biased. But you're also asking them because it's convenient, right? So kind of a couple errors there. Not always the best right there. You select at random, a class at random, and then like the sample, you select the sample class at random and question each student in the class. What that is just a straight up random. Not simple random, but just straight up random. And last, you assign each student a number and after choosing a starting number, question every 25th student. What is that? That's going to be systematic. Every 25th student, every 10th student, and so forth. Okay? Awesome. Awesome, awesome. So that was all the lesson is. No math at all. We were going to take a break with that. We took a break today because that is a great introduction to stats, kind of how to do a statistical survey. So we're going to get the ball rolling in the next couple of lessons with 5.1, 5.2, and 5.3 in actual Unit 8 statistics in what we call the normal distribution. Okay? But what did we learn today? Distinguish between a population and sample. In 1.2, we distinguish between qualitative and quantitative data. 1.3, we learned how to design a statistical study and how to distinguish between observational study and experiments. And then, of course, we created a sample using we learned how to create a sample using the following sampling techniques: so random, simple random, stratified cluster, and systematic. And then we also learned how to identify some bias in specific areas. So if you have any questions on the homework, please email me and ask. But the homework will be on Math Excel. Like always, you will have a homework quiz tomorrow, so make sure you do the homework. But until then, this is C Squared Mathematics. I'm Mr. Carlson. Peace.